with Biot number, students. Biot number is about conductive resistance by convective resistance, which is R naught by K divided by 1 by Hc, which is Hc R naught by K. So, yeah. So, if continue, today is 16th, right? If Bi tends to 0, then Rk, which is equal to R naught by K, tends to 0, or R convectivity, which is equal to 1 by Hc, tends to infinity. It means either conductivity is very high, or or convection heat transfer. Convection heat transfer is very low. Convection heat transfer is low. Understand this? You got the things? What's happening? Oh, Bharat has come. Come. He was waiting for me to start. I was waiting for you to come. You were waiting for me to start. I know you are outside only. Similar thing, other side. You understand why? Biot number less going to 0 means conductivity or this convection heat transfer is very very low. Convection does not happen at all. It might be in vacuum. Biot number heading to 0 means the body can be in vacuum and only conductivity is happening but not outside, not going outside. That is what means Biot number tends to 0. The temperature remains almost constant everywhere. Okay. Next, similarly, and right here only, if Biot number tends to infinity, then Rk tends to infinity, Rc tends to 0. Means low conductivity, high convection. Low conductivity, high convection. Very important. This concept which is there, which I have told you, is very 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 important. Lot of questions have come on this. Today also in your JE, this question may appear. I'm not sure because that's a diploma level. So I'm not sure whether this question will come or not, but may be coming. Biot number ಡಿಪ್ಲೊಮಾದಲ್ಲಿ ಇತ್ತ ಇರಲಿಲ್ಲ ಅಲ್ಲ, ನೀವು ಡಿಪ್ಲೊಮಾ ಮಾಡಿದ್ದಲ್ಲ, PUC ಬಂದು ಗೊತ್ತಾ? ನೆಕ್ಸ್ಟ್ ಹೋಗುವ. ತೆಗಿರಾ ಫೋಟೋ ತೆಗ್ರಾ? ಸ್ಮೈಲ್ ಮಾಡ್ಲಿಕ್ಕೆ ಹೇಳಿದ್ರಲ್ಲ. ನೆಕ್ಸ್ಟ್ ಸ್ಪೆರಿಕಲ್ ವಾಲ್ ನೋಡು. ಸ್ಪೆರಿಕಲ್ ವಾಲ್ ನೋಡು. ಮತ್ತೆ we'll go with spherical wall is the same thing. There's nothing here. So spherical wall ನೋಡಿದೆ. What is the equation in the spherical wall? One dimensional heat conduction. for one dimensional heat conduction. 1 by r square into d by dr into r square dt by dr. Third one. So I can write here, when you integrate, you get r square dt by dr is equal to constant. Or I can say C1, or I can say dt by dr is equal to C1 by r square. I need to rush here because 11 o'clock I have to complete. So all these things are general. You can see that. Now what happens? T of r is equal to r square. When you integrate, what you get? You have to do plus 1, right? Minus C1 by r plus C2. Agree? So how do you put at r is equal to r naught, c is equal to r is equal to r naught, t is equal to t naught, gives gives c2 is equal to t naught. Right? Or outside, or we can write inside also. We'll have inside ri. Let us have inside c2 is equal, whichever you pick. C2 is equal to I. Then what happens? At, or we can have like this. Okay, don't want this. Wait. C2 is equal to Ti. No, it's not. C2 is not equal to Ti. I'm sorry. Very sorry. C2 is not equal to Ti. When R is equal to Ri, T is equal to Ti. So what happens here? T of Ti is equal to minus C1 by Ri plus C2. And at R is equal to R naught, T is equal to T naught outside. Okay, this is inside. I means inside. I inside. O. Okay, like this we'll assume. So we'll get T naught is equal to minus C1 by R naught plus C. When you solve these both, you will see that we can write, when we solve this, we can get it this way. Ti minus T naught is equal to minus of C1 by R naught minus C1 by Ri. Correct? Or we can write C1 is equal to Ti minus T naught, Ti minus T naught into Ti minus T naught, divided by 1 by C1 should be, I'm putting the bracket here. Okay, okay, then this should be plus. Now it's proper. No, it's not proper. I'll put it like that. Minus C1 by Ri plus C1 by R naught. Fine. So now this would be equal to divide by 1 by R naught minus 1 by Ri. You are comfortable with this? Right. We are comfortable? C1 is equal to Ti minus T naught 1 by Ri 1 by R naught. Or we can see C1 is equal to, if you take it above, you will get R naught Ri into Ti minus T naught divided by Ri minus R. Make sense? Apply that there. And then find C2. Now that means applying in, if you say applying in one of those equations, okay, applying in one of the equations, so you say R T of R, T of R, okay, no, yeah, one of the equation you will get C2. Ah. So let us say this is E, this is B, this is C. Applying D in C, you written this down. Then apply that back and see what you're getting. Continue, continue. Don't worry. Same thing. What I am doing, you're doing is same. A bit of difference is there, that's okay. If there's a bit of difference between what I do and what you do, if it follow the proper procedure, we'll get it. It's a problem. It's not a, so now further going. Done. Then writing this, everyone. Now what we can write? Applying D. Bani. New, you can do one thing. See, uh, one second. Done. Okay. Applying, applying D in B. If you apply D in B, you will get Pi is equal to minus 1 by Ri into C1 will become equal to R naught Ri divided by R naught minus Ri, correct no? Sorry, Ri minus R naught. Ri minus R naught into Ti minus T naught. Ti minus T naught. Agreed? Ti minus T naught plus C2. What happened? Anyway, you have to put it in T naught. You get the same thing. Don't worry. Don't think that it's a what to say. It is a derivation. It is not a derivation. It's a problem. Okay, it's a differential equation problem. That's it. Okay? And these things you don't need not remember much. Okay, if you can remember, well and good. If you don't remember, don't worry. That's it. So C2, you get it as Ti plus R naught Ti minus T naught divided by Ri minus R naught. This is equation E. Into 1 by Ri cancels. No? So we have R naught. Now, applying E directly. Tell me, don't worry. Yeah, yeah. C1, this C2 we have to apply to the final equation. C2 in terms of T naught. Yeah, you can do that. Same thing, right? Okay. C2 we could have got in terms of T naught also. Instead of Ti, what you know is important. Okay. So applying E and D, that's why I said it is a problem. It is not a derivation. Okay. So we get this, we can write this as T of R, we could have got T of R is equal to minus C1 by R minus C1 by R, that is 1 by R, 1 by R into, we should write R naught Ri into Ti minus T naught divided by Ri minus R naught into R naught plus C2 plus C2, which is equal to Ti plus Ti plus R naught into Ti minus T naught divided by Ri minus R naught. Let us take this Ti the other way around. So we'll get T of R minus Ti is equal to, let us take R naught outside and R naught minus Ri outside. So if I do that, what I'll get here is Ti minus T naught will get here. And then if I take R naught minus Ri minus R naught outside, then inside I can get here 1 minus R by R naught. Ri by R, is it? What does Ri come there? Ah, yeah, yeah. You're taking R naught outside. You're taking Ri, not R naught, R. So this is the equation. This is how you can get the temperature. Done. Similar way, we can do if there is a heat generation also you can do it, but we are not doing it. Only thing is that you have to remember the heat conduction equation, and then you have to just do the derivation. And derivation, because I did it here, it took time. Otherwise, it is 2 minutes. You can do the derivation. There is no problem in it. And the questions that is coming in gate is also easy. You will see the question type. Okay, you have to do afterwards. Okay, tomorrow morning or anytime whenever you are free, you're going to revise these problems. Okay, what we are doing from 11:30 onwards. Done. Banta ಎಲ್ರಿಗೆ ಬರ್ದ್ರಾ? Either don't worry about these things. See it again and again. It will come. ತದ್ ಸರ್ ಇಷ್ಟು ರಿಮೆಂಬರ್ ಮಾಡ್ಬೇಕಂತ ಹೇಳಿ ಆ ಥರ ಎಲ್ಲ ಯೋಚನೆ ಮಾಡಿ ಆಗ್ತದೆ. There has to be a type of, what to say, Ashley at the end he used to say that, sir, it's so easy, sir. We thought something was there. It's nothing. You go step by step, everything happens. Correct. It, the moment he came, sir, I should have prepared a bit more, sir. That was one of the things he had at the end. Sir, I wasted time. Yes, he wasted time. 1 month he wasted. We completed in around November, no, December 10th or so. From December 10th till January 10th, he was wasting time like anything. He said some problem had happened, I don't know, but he could have been more serious on that. The problem comes when you take the problems. Problems are there, but don't take it in your mind. So something happened, some renovation, home renovation or something was happening in his home. So, okay, anyhow. So he said if I prepared 1 month there, I would have done very well. He got 64 out of 100. Okay, he could have done it. I think he's so capable that he would have got another 10 to 15 marks easily in that particular exam. Okay. So, like that. Anyway, so next, critical radius of insulation. Very important. It's so critical that it comes a lot of times. It comes in almost every exams, okay, of insulation. Almost every exam is an exaggeration, but you understand the gravity of this particular topic. Okay? It's one of the favorite that I can say. And this is important because, see, if I have a cylinder, this happens only in a cylinder as well as a sphere. Only two places this critical radius of insulation takes place is important. See, sometimes what we do is, let us take a case of a cylinder. Let us take a case of a cylinder. Let us take, this is a pipe, heated pipe where steam goes. Okay, this is a steam pipe. Okay, steam is going inside, and this has a temperature TT. TT is the temperature of the tube. You're seeing that it is having a lot of you need to insulate. You don't want that whatever is heated in the boiler, that heat to pass out. So what do? You put some foam insulation, generally or glass wool insulation. What do? You put some glass with critical radius of insulation. Critical radius of insulation. Let us see what does it mean. What is mean by that? Okay. So what happens? We have a tube. We have done a very nice things last time, but now it's okay. Now we have a tube which has a temperature of T, T of the temperature of the tube. Okay. Now you have to insulate that. Maybe this tube is made out of cast iron or GI. Okay. We don't know what is the tube material is. Okay. Tube material can be generally galvanized iron. Okay. So when you have a galvanized iron tube, now there is steam inside. In case you have steam inside, you want the heated steam. The heat should not go. If it goes off, then what happens? Steam starts condensing, and you cannot use it in the steam turbine. So what do? You decide to insulate. You decide to put a wool. Okay, what wool? Sometimes glass wool you put so that there is insulation. Okay, but then if it so happens that because of the glass wool you put, the heat transfer instead of reducing increases. Possibility is there. What is that possibility? Why that possibility is there? I will tell you now. Okay. So now let us have this like this. Let us have in this tube. So let us say this is this side, and then over here. Okay. Okay. So let us say heat transfer is happening in this region in this fashion somehow. You have here TT, then there is a resistance, then there is a resistance, and then it goes to T infinity, right? So you have T of the tube, that is a wall, then you have the insulation resistance, and then you have the convective resistance. This is the T insulation at the end of the insulation. Okay, this is R, this is insulation, this is insulation, and this is convective resistance. And here is T infinity. Fine. Okay. So this one R resistance would be equal to XW, the wall thickness, divided by we have L by K into A log mean, correct? And this one would be the thermal resistance or the resistance due to insulation, is it not? Or due to this. So what this will be, this R would be equal to 1 by area into length into H convective of the air, right? Whatever the air or anything is. Fine. So if you say Q or T T minus T infinity is equal to Q into R1 plus R2. What is R1 plus R2? R1 is XW divided by A log mean, or we can write this as log of R naught by Ri of the insulation. Okay, this is R naught, we will say. This is Ri. Okay, of the insulation we are talking about, into 2 pi K of the insulation into L. ಏನಾಯ್ತು ತಪ್ಪೇನಾಯ್ತು? ಹೌದು ಅಲ್ವಾ? ಏರಿಯಾ ಎಲ್ಲ ಏರಿಯಾದಲ್ಲಿ ಬರ್ತದೆ, ಕರೆಕ್ಟ್. ವೆರಿ ಗುಡ್, ಗುಡ್ ಇನ್ಫಾರ್ಮೇಶನ್. 1 by HA. ಏರಿಯಾ ಏನು ಬರುತ್ತೆ? 2 pi R naught into L ಬರುತ್ತೆ ಅದು. So this would be 1 by 2 pi R naught into L into HC. Make sense? Correct now. TT is the temperature at the inlet, Ri here. This is the TT here. So not here. Outside. Oh, I'm sorry. Here I made a mistake. One second. There's a mistake. Wait a minute. Yeah. Yes, yes. Here you have TT. Then you have insulation. Then you have convection. R2, R1. It's not the inside one. So that we are worried about the temperature of the tube and inside insulation, outside insulation. The temperature of that steel tube is important. Now doing this, we will see that Q is equal to 2 pi L into Tt minus T infinity divided by divided by. If you do the proper this one, you will see you will get it as 1 by Ki into log of R naught by Ri plus 2 pi comes outside. You understand? 2 pi L comes outside into 1 by Hc into R naught. K insulation. Okay. K insulation. Correct. Simple. Take time. Take time. Understand. Done. Next. Next one. Now here, when is the heat transfer maximum is the question. You want to reduce or you want to increase? One of the two. Let us see. Okay. What is dq by dr naught? What is that will be? If you put dq by dr naught is equal to 0, to find the maxima or extremum. We are trying to find the extremum. Let us see how to find the extremum. Okay, it might be maximum, it can be minimum, we'll see. Okay, that means if I increase the thickness, what is going to happen? That's what my point is. If I do that, we will get dq by dr naught, because dri I cannot change, I can change only r naught. Okay, so that would be equal to minus 2 pi L into T of t minus T infinity into 1 by Ki 1 by Ki into R naught, R of, yeah, what did I write? Ri here, is it not? Ri. So what you will get here? You will get with respect to R naught, is it not? So with respect to R naught, when you differentiate, which is there in the denominator, okay, it's there in the denominator, dq by dr naught you are taking. So what you will get here is, see, 1 by log is there, is it not? This is related to r. So what will happen when you differentiate? How do you differentiate this? Log of, see here, we have 1 by log of r naught by ri. How will you differentiate 1 by log of r naught minus ri? That we can do it. Sorry. So if I do that, okay, let us do it. So if I have log of, sorry, wait. So let us understand this. Okay. So this particular thing, I can write it as ki is there. So let us go that side. So okay, okay. I'll write this down. Okay, let us do it. Let us do the derivation. Okay. So dq is known, is it not? So I can write dq or q is equal to. Let me write like this: q into 1 by ki log of r naught by ri plus 1 by h naught r naught is equal to 2 pi l into t I minus t infinity. Correct? Huh? Yeah, t minus t infinity. We'll differentiate that. Just a second, students. Or should we differentiate the same thing there? 1 by log, is it not? Okay, let us do like this. Okay, let us do this. Wait a minute, students. Again. Let us do this. We will write q is equal to 2 pi l tt minus t infinity divided by, can we write 1 by ki into log of r naught minus log of ri, students just see here, plus 1 by ha into r naught. Fine. Now how can we lower this still? How to differentiate? dq by dr naught is equal to, now what will happen, 1 of something function of x, differentiation of function of x, 1 by function of x is what? Not ln, is it not? It's ln minus 1 by f of x square into f dash of x. Yes or no? Correct, no? With a minus. Correct. So this will come as 2 pi L tt minus t naught into 1 by ki log of, let us keep it like that only, r naught by ri, let us not have this, okay, ri plus 1 by ha r naught square. Let us again differentiate this. When you differentiate this, you will get 1 by ki into log of r naught by ri, 1 by r naught, correct, 1 by r naught, then you have r naught by ri, which gives you 1 by ri, correct, sorry, log of, you get ri by r naught into 1 by ri. Agreed? Why? Because log of r, differentiation of log of r with respect to r is 1 by r. So differentiation of log of r naught by ri is equal to ri by r naught. Agreed? Convinced? Everyone? So this would be 1 by ri 10 minus 1 by ha r naught square is equal to 0. Make sense? Hello. 1 by har naught is there. So this same thing. Minus 1 by fx square into fx. Ri. Because you have again r naught by ri. Clear? Differentiation is clear, everybody?
Sir, but you're differentiating with respect to R naught, no, sir.
Exactly.
So how are you differentiating Ri in that again?
I'm not differentiating. See what I have. Log of r naught by ri when I differentiate. D of dr naught of this would be equal to would be equal to Ri by R naught. Then d of R naught by Ri, correct? Yes or no? What is d of log of R naught by Ri? Correct. So what you will get? You will get Ri R naught into R naught. Sorry, R naught will go as 1, so 1 by, or d by dr naught. I'm sorry, d by dr naught. Make sense? Yeah. So once we
Yes,
do
sir.
that, correct, no?
So if you expand it and then differentiate, I think it's more clear, I guess. I mean, you get 1 by R naught minus 1 by Ri into dri by dr naught.
Same thing you get. You get the same thing.
No, dri by dr naught you get, I guess.
Where dri by r naught? Oh yeah. I'm sorry. I'm sorry. Here you get it as, uh, no, 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 no. R naught by Ri only. See here, this is log of R naught by Ri. Is it not? What I'm differentiating? Log of R naught by Ri. Yes or no?
Yes, sir. But now if you expand it, log of R naught minus log of Ri.
Don't do that. Don't do that. This will skip. Not required. This.
No, like even if you do like that, also the answer should be same, no, sir.
You should get it, but let us not worry about it now. Okay.
Okay, okay.
So I hope this is proper. We have not done any mistakes here. That's what we will see. Okay. H of convection, HC we have used, H of convection into R naught. Any problem we have done? No, right? Minus we have missed. We have missed a minus. You want me to do the differentiation again? You want me to do that? Okay. I'll do it again. Wait a minute. I'll do the differentiation again and I will show you how the thing is. Okay. So what happens? dq, or we have q is equal to 2 pi L t of t minus t of 0 or t of infinity divided by 1 by ki log of r naught by ri plus 1 by h a h of c into r naught. Correct. This is the question. Now first thing what I am using is 1 by d of dx of 1 by f of x is equal to f, f of x would be minus 1 by f of x the whole square into f dash of x. Fine, that's what I'm using. So I will use dq by dr naught is equal to 2 pi L tt minus t infinity into 1 by, what is f of x here? This particular part. I will write 1 by ki into log of r naught by ri plus 1 by hc into r naught the whole square. Now you have to differentiate f dash of x. So what you are doing, you are differentiating this. So if you see here, this will come as, now we are differentiating. Okay, there is a minus here which we have missed obviously. There is a minus 1 which we have missed. We'll put that minus there. Okay. Then here we will have 1 by ki. Now we have to differentiate log of r naught by ri. What is differentiation with respect to r naught? I'll write it a bit low because it has to come d by dr naught of log of r naught by ri. If you see, you will get this as r naught, sorry, ri by r naught into 1 by ri. Why do we get this? Because log of differentiation d by dx of log of x is equal to, sorry, log of x, say log of, say let us say 1 by x, log of 1 by x. okay, or log of a by x, a by x can be equal to, here you get log, so x by a or 1 by a. You understand? 1 by a. And then you have to differentiate this x again. Or we'll write, yeah, this will come as, yeah, it is r naught in the top, is it not? So x by a, x by a would be equal to 1 by a, here first of all 1 by a, or yeah, 1 by x, or a by x, I'm sorry, a by x into differentiation of x by a, d by dx of x by a, which will give us a by x into 1 by a. Make sense? Chain rule. So this would come as, are you convinced, mister?
Yes, sir.
Ri minus, he's into, okay, don't worry. Okay, don't worry. Okay. So here this would become as equal to h c into r naught square. Now this is going to be equal to 0. What comes? Everything else is eaten up by the 0. What is remaining is 1 by ki into ri by r naught. Ri by r naught is also not there. 1 by r naught minus 1 by hc into r naught square is equal to 0. Or 1 by ki r naught is equal to 1 by hc r naught square. Or at the end what we will get is r naught is equal to ki h. Important. Ki, very, very, very important. The equation number is 20, 21. This let it be 22. It is very, 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 very important. Very, very important. The previous one we will leave. The For that we will not put any number. Or should we put that? Or uh, spherical, this one. Or temperature we will put it as 22. Let this be 23. For the temperature profile we will 22 and this will be 23. Fine. This is very important. Now whether it is maxima or minima, we do not know. How do we know that? We have to again differentiate it. You have to differentiate this again and then find out. That is one way to see. Another way is, another way is, I'll come write this down. Just let us plot and see whether maximum is coming or minimum is coming. Nowadays we have computers. We can plot easily. Let us plot it. Very, very important, students. Very important. I'll extend a bit. I'll extend a bit. Okay. 5 minutes. I think anyhow they have a scooter, they can go fast. Okay. Done. Next. Another punch. Okay. Now here, see, we'll plot Q versus, let us plot Q versus R naught. You increase R naught and see for the same H, same for the same conductivity, everything. You will see that as R naught increases, Q naught increases and it comes to this. And this maximum corresponds to R naught critical. which bases itself, and this R naught critical is actually equal to R naught critical is equal to Ki by Hc, or K insulation divided by H. Now in case, now the problem is here. Now in case you are over here, your insulation is here, Ri is same here. Observe. Now in case your steam pipe is so big, steam pipe is so big that you fall in this region. Now if you are in this region and you add insulation, then what happens? You're going to increase the heat transfer. The purpose of insulation is not served. Make sense? If you are over here, the radius of the steam pipe is less than, if the radius of the steam pipe of the tube is less than critical radius for a type of insulation, very important, for a type of insulation, that is RT or Ri is less than R critical, then insulation increases heat transfer. Insulation increases heat transfer. That is what is done in our electric wires. Electric wires are insulated. Two purposes are there. One purpose is give electrical insulation. Second one, to increase heat transfer. You put insulation to increase heat transfer. You understand? We'll see that. We'll see that how does it increase in heat transfer. We can help. We can reduce. If you want to reduce heat transfer, we can use. If you want to reduce heat transfer, we can use insulation with lesser conductivity. If we have a type of insulation, say wood as a particular insulation. Now we can't use wood here. If the wood with respect, see, it depends on K of the insulation. If the insulation material can be used which has much lesser conductivity, then it may help. So that for that insulation, R is less than this. Makes sense? So that its peak is somewhere here. You understand? You have to use some other insulation. One type of insulator. One type of insulator being used. You have to use an insulator with a higher, with lower conductivity. Then it is possible. So you have to have an idea of what is the critical radius of insulation with that insulator and with that H. But H to reduce, see H, what is happening? As H increases, critical thickness increases. Sorry, H increases, critical thickness reduces. But do you want to do that? You don't want to do that. You want to stop the heat transfer. When you increase Hc, what is going to happen? Heat transfer is going to increase further. Make sense? So at any cost, you don't want to increase Hc. You want to reduce Hc as possible. No, no. Wind is coming. Wind is depending on Hc. If there is a forced convection, Hc reduces. You can reduce Hc by putting a vacuum around it, or you can increase Hc by putting vacuum around it. Still, you have to think about it, students. A lot of thinking has to be done here. It's a simple concept, but it's very, 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 very important because it is used in power plants, because power plants are there, part of every big industry. Keep in mind, you talk about iron and steel, a power plant is there along with it. You talk about a chemical processing factory, there will be a power plant nearby. So power plant is something which is very, very common, very common. Every industry wants, suppose an automobile industry only, if it becomes so big and it cannot take electricity from the grid always, because it's unreliable. It's always better if they have a power plant inside. Any big industry that consumes power would want a power plant, inbuilt power plant, so that they'll reduce the cost, and they do it. Like we had our say we had went to Mandya once. Okay, in Mandya there was a sugarcane factory, and that sugarcane factory had an inbuilt steam power plant, steam power plant, thermal power plant. How the after the squeezing of this sugar cane, whatever is remaining, that's very, very dry, they burn it. They dry it in sun and they burn it, and use it, that burning is used in the boiler, and that uses that steam. I was astonished, they use that. Yes, they use that, and whatever heat is produced, a lot of things happen. That is converted into steam. They have a steam power plant, and the size of it was 5 megawatt or something like that. 5 megawatt steam power plant was there. Fantastic, is it not? IO10, I'm not sure about it, but it's not like 200, 300 megawatt that what we have here in our. That is enough for a sugarcane factory or sugar factory, is it not? Oh, that's how it is. So this is about insulation, critical thickness of insulation. What is it? Ki by Hc. That's it. We will do one or two problems. Fine, which is come in gate. 10 minutes. Can you stay for 10 minutes more? So depending on your decision, okay. So this is to help our students writing SSEG. Okay. Now similarly, one more point I'll not derive, but I will tell you. Okay, this is one point I have to tell you. The point is like this. Okay, this is for a cylinder, but if it is for a sphere, okay, for a sphere, very important. For a sphere, for a sphere, critical radius, critical radius of insulation. For a sphere, critical radius of insulation is RC for sphere is equal to 2K insulation divided by H. You have to multiply that 2 then. So for the same um, insulation, you need higher radius, twice the radius as that for the cylinder. Okay. So let us do one problem. It's simple question is there. I want to have a bit of complicated. See, there is a very simple question also here. Okay, this is a very good question which has come in 2016 question paper. I would don't write the question. Okay. Just let us see. 10 minutes more, students. 2016 mechanical engineering set 1, a plastic steel. Yeah, yes, it's very common, students. It's a common question. Yeah, will you solve the students? Don't write the question. Gate 2016 set 1, ME 2016 set 1. So a plastic sleeve of outer radius R0 is equal to 1 mm covers a wire carrying an electric current. Thermal conductivity of the plastic is 0.15. The heat transfer coefficient from the outer surface of the sleeve is exposed to air is 225 watt per meter square Kelvin. Due to addition of the plastic cover, the heat transfer from the wire to the ambient will increase, remain the same, decrease, or zero. So what is happening here? We have to find what is R critical. What is R critical? It is a electric current. Okay, a plastic sleeve of outer radius covers a wire. Wire is 1.5 mm. Plastic sleeve of outer radius is R0 is equal to 1 mm. So what is Ki? Ki by Hc. What is Ki? Thermal conductivity of the plastic 0.15. Thermal conductivity of the sleeve, oh sorry, the air, the heat transfer coefficient is 25. So what you will get 0.15 by 25. So you get this as 0.0375. Is it not? No, 35. 35. 00. 6, right? So meters. So it is 6 millimeters. So 6 millimeter is the critical radius, and this radius is 0.5 mm. And if you make this zero point 0.5 as 1, then what is going to happen? It's going to increase, is it not? The heat transfer due to addition of the plastic cover, heat transfer from the wire to the ambient will increase. Make sense? It will decrease. 0.5, no. The outer radius is given as 1 mm. Not 1.5, it's 1 only. Outer radius, this is given as 1. Reading comprehension. Reading and whether you comprehend whatever is given. This is one of the aptitude. One question will be there on comprehension. Chalo. Next question has come in 2015.
Sir,
Yes, please.
in this, by just looking at the question, I mean, HC is all, however, greater than K now. Can you not decide using that?
What can we decide?
I mean, heat transfer is increasing because HC, I mean, to the surface is greater. No?
Exactly. Correct. That is one of the way you can do it. 100%. What is happening? HC is increasing. Area is more. Log mean area is less. That is the basis of this. So when HC is greater, Ki is less. Log mean area, this area is lesser compared to this. That is one of the ways to get it. Okay, but more deeper, I will go in the next class. Okay, one more question. Similar question has been given in 2015 for 2 marks. Okay, 2015 2 marks question. This is also come here. Okay, let us do that. This is a common question, students. One more question, then we will stop. Okay. I hope you're not feeling this is 2015 last question. I'll give you, then you can go. Okay. 2015 set one. Okay, 2015 2 marks. 10 mm diameter. It is. It's a 2 mark question saying a 10 mm diameter. Yeah, this question. Question number 60. Okay. This question. So this is 2015 set 2 question 60. Set set one. Set one. Yes, take it. Suppose. See, we have stopped just like that when he came. You see that? That is what is called intuition. The R critical is 8 mm. So what is the answer? What is the diameter of the conductor? 10. So what's going to happen? Diameter. Yes, there is a point there. It is diameter. This is radius. So it is 8 mm diameter. 8 mm radius. So what is the radius of the insulation now? The radius of the wire is 5 mm. It is given as 2 mm insulation. Okay, so it is 7. So here the conductivity of insulation. Okay, further insulation, further, see the question properly. Further will increase the heat loss to the maximum and then decrease the heat loss. Had this been instead of diameter, had this been radius, then what would be the answer? Answer would be decrease heat loss continuously. So we have to be very careful where we are. I'll go into the deep in the next question. Next. So we'll meet at around 11:45. Okay. I hope you got the answer. Got the this. Thank you.